All right, let's get right into it. Today, we're talking about a really fascinating new scientific paper that kind of reimagines the very fabric of our universe. It's a new framework where space-time isn't just this empty, passive stage, but a super active, dynamic medium.
It all boils down to this one massive question. With all our incredible science and telescopes, we still have basically no idea what 95% of the cosmos is actually made of. We have these names for it, right? Dark matter, dark energy, but let's be honest, they're really just fancy placeholders for a mystery we haven't solved. And that's exactly why fresh ideas like this one are so important.
So, to really get why this new theory is a big deal, we have to look at what we're working with right now. The reigning champion of cosmic theories is something called the Lambda CDM model. It's been amazingly successful for sure, but it's also got some serious holes.
And you can see the dilemma right here. On the one hand, Lambda CDM does a fantastic job explaining huge things, like the leftover heat from the Big Bang, or why galaxies tend to clump together in massive webs. But on the other hand, the mysteries it leaves behind are just profound. Ask it what dark energy is, and it kind of just shrugs. It can't really explain the weird behavior of those vast empty spaces we call cosmic voids, or what's holding galaxies together so neatly.
Okay, so how do we even begin to solve these problems? This is where the paper from Michael Firkus comes in and proposes a pretty radical shift in our thinking. It basically says, what if we've been looking at spacetime all wrong? What if it's not a passive background, but an active, flowing medium? The absolute core idea here is what's called the flux medium. So forget thinking of the universe as a fixed stage where the cosmic drama plays out. Instead, I want you to imagine spacetime as a vast, deep ocean. It has currents, it has tides, it has flows of energy, and all of those things are actively shaping the evolution of everything in it. It's a total change in perspective. Now, you might be thinking, are we just throwing out Einstein's general relativity? And the answer is no, absolutely not. That's what's so clever about this. It doesn't replace Einstein's work, it builds on it. It suggests that Einstein's cosmic recipe is maybe just missing a few key ingredients to really capture this dynamic nature of spacetime. And this framework gets very specific. It proposes adding 3 new types of energy and pressure to the cosmic mix. And these aren't just random guesses. Each one is carefully designed to tackle one of those specific puzzles that the standard model can't quite solve. So let's quickly break down these new ingredients. First up, you have T-flux. Just think of this as the energy from the actual flow and currents in that cosmic ocean we talked about. Then there's T-dark, which is really cool. It acts like a cosmic thermostat, a sort of feedback loop that helps regulate all the energy in the universe. And finally, T-buoyancy is a stabilizing force, kind of like how a ship floats in water. This could be what keeps giant structures like galaxies from just collapsing in on themselves. So you add all these new dynamic forces into the equations for the universe. And what do you get? Well, what you get is something that's surprisingly simple and elegant. You get a clear way to figure out if any part of the universe, or the whole thing, is going to expand, collapse, or just find a stable balance. And this is the magic of it, really. All of that incredibly complex physics, the flows, the feedback, the buoyancy, it can all be boiled down to a single critical number. It's called an eigenvalue, and the paper calls it lambda, just one number that acts like a master switch for that part of the cosmos. So how does this switch work? It's pretty straightforward. If that master number, lambda, is positive, greater than 0, then things expand. The universe grows, or structures like galaxy clusters form and get bigger. This lines up perfectly with the accelerating expansion we see all around us. Okay, now what if lambda is negative? You get the opposite. Things can decay or collapse. But, and this is really important, it also allows for stabilization. A system can use this force to push back against gravity and hold its shape. This could be a totally new way of thinking about why cosmic structures are so stable. But here is the most mind-bending possibility of all. What if lambda is really, really close to 0? Well, that suggests the universe, or parts of it, could exist in a state of near-perfect equilibrium, a delicate cosmic balancing act between all these competing forces. Okay, I know what you're thinking. This all sounds really cool, but is it just a beautiful idea on a whiteboard? Can we actually test it? And the answer is yes, we can. One of the best things about this theory is that it makes concrete, real-world predictions that our astronomers can actually go out and look for. So, what would we be looking for?
Well, the paper lays out 4 specific clues. First, it predicts that gravitational waves might actually get stronger or weaker as they travel through this flux medium. Second, we might be able to spot tiny, buoyancy-driven wiggles or oscillations in super dense objects like neutron stars. Third, the universe's expansion rate might not have been a smooth ride. There might be bumps along the way. And finally, those giant cosmic voids might grow in strange, unexpected ways depending on their size.
And that's really the whole point. As the author, Michael Furcus, says himself, the goal here is to come up with an alternative that makes physical sense. It's not just a mathematical trick. And most importantly, it's something we can actually put to the test with real observations.
So I want to leave you with this one last thought, which is pretty profound. What if the story of our universe isn't just about this endless passive expansion into the cold and dark? What if instead it's a much more active story, a story of dynamic forces constantly pushing and pulling, always seeking, and sometimes finding, a perfect balance? That's the incredible possibility this new idea brings to the table.